Okay, here we go. We're going to simplify some radicals. Yep, 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 yep. I feel like we got to talk really fast because these little chicks look like they'd be going yep, 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 yep. And here we go. If a squared equals b, then a is the square root of b. Okay, this thing right here is known as a radical. Most of you call it a square root. That's because when there's no number here, we assume that it's a square root. You're going to learn about other kind of roots next year in Algebra 2. But for right now, we're going to call it the radical. The thing underneath is called the radicand. So when we are simplifying, we're going to say, is there a number? So something times itself that equals 100. That's what we're thinking of. Well, hopefully you know that 10 times 10 is 100. So the square root of 100 is 10. And then they have this plus or minus sign in front of here. So when they're saying plus or minus the square root of 100, they're saying what number times itself gives you 100, and it's a positive. Well, that's going to be a positive 10. What number times itself gives you 100 and is a negative, and that's going to be a negative 10. So instead of writing both of them, we just put this plus or minus sign. On this one, they want a negative answer, so we're going to put a negative. Square root of 36, well, 36 is 6 times 6, so the square root is 6. 49 is 7 times 7, so the square root is 7. When you have a perfect square, such as 100, 36, or 49, when you say, what is the square root of 36, it is 6. People want to say it's the square root of 6. Nope, because if you multiply 6 times 6, you get the square root of 6 squared, and here's a little secret. The square and the square root cancel each other out, so that's how you get just 6. So do you know the square root of 121? Well, it is 11 times 11, but see that negative right there? What is 11 times 11? It's 121. It's not negative 121. What is negative 11 times negative 11? It's 121 because a negative times a negative is a positive. The only way you can get a negative is multiplying a positive times a negative. Those are not the same number, so this one does not exist. There is no square root of a negative number. So in your books, you're going to put rule number 1, square root of a negative number does not exist. Okay? I want to see that when we check to see if you did the work. Is there a square root of 72? Is there a number times itself that gives you 72? Hint, hint, there is not. So we are going to learn what is called hedging. It's technically not called hedging, but that's what we call it here at Jefferson High School. In other words, that's what I call it. It is actually called finding the prime factorization. So your teacher might find the prime factorization, or they might say hedge that. What we're looking for is, are there any perfect squares under 72? Because remember, if I have the square root of 6 squared, the square and the square root cancel. So we're going to use our prime numbers. So in your list, in your book, I want you to write down the prime numbers. You need to memorize these. 1 is not really prime. So we're going to write it, then we're going to erase it. That's our ultimate goal, though, is to get to 1. 2, 3, 5. That's a 17. That's supposed to be a 7. 11, 13, 17, blah, blah, blah. Basically, 2, 3, 5, and 7 are the numbers we're going to try. So I'm going to take 72 and I'm going to do what is called upside down division. So I'm going to put an upside down division sign. Which one of these prime numbers, 2, 3, 5, or 7, goes into 72? Well, 2 does. Now you can go over here and say 72 divided by 2, 3, 6. So it equals 36, okay? Divide it by 2 again. Here's the deal. Once you start with 2, you are committed to 2 till it stops working. Does 36 divide by 2? It does. It's 18. Does 18 divide by 2? It does. It is 9. Does 9 divide by 2? It does not. So now I have to switch to another number, and I'm going to switch to 3. 9 divided by 3 is 3. 3 divides by 3, and remember I said our ultimate goal is 1. So here's what you have. In the prime factorization, you have 2 times 2 times 2 times 3 times 3. Now, We're going to go through a real long way, and then I'm going to show you the short way to do it. So you're like not even going to listen right now. 2 times 2 is 2 squared, right? 3 times 3 is 3 squared, and then there's another little 2. What did we say about the square and the square root? They cancel, so that brings me out a 2. See those two 2's there? Here's the shortcut. I'm going to circle those two 2's and say the square root of 2 times 2 is 2. Here's a 3 squared. The square and the square root cancel, so it brings out a 3. So here's a 3 times 3. That brings out a 3. That one little 2, it is not with a buddy. It is not a perfect square, so it stays inside. So here's the real rule now. Everything outside gets multiplied. So 2 times 3 is 6. Everything inside that didn't come out, that didn't have a buddy, stays inside the radical. So your final answer is 6 times the square root of 2. Now I'm going to tell you that in middle school you learned prime factorization this way. You did 2 times 36, and then you did 2 times 18, and then you did 2 times 9, and then you did 3 times 3. And that's fine. That's called a factor tree. I don't use it because I tend to lose factors. So there's what you're going to do though. There's a pair of 3's that brings out a 3. There's a pair of 2's that brings out a 2, and you have the 2 left over. I call this a hedge. I like to stay in the fauna family. Tree, hedge. So we're going to call it hedging in this video, okay? So 52, it does not have a perfect square. So I'm going to take 52 and I'm going to divide it by the first prime number I think of, which is 2. And you can go to your calculator, you can do regular division, but you got to do the answer upside down. It's going to be 26. 2 will work again. It's going to be 13. 2 does not work. 3 does not go into 13. 5 does not go into 13. 7 does not go into 13. 11 does not go into 13. Oh, wait. 13 is one of our prime numbers. Remember, you got to get all the way down to 1. So now you're looking for perfect squares. 2 times 2 happens to be 4, which is a perfect square. The square root of 4 is 2. So I bring out the 2. What didn't make it out? Well, the things that didn't make it out also get multiplied, and that would be 13 times 1, which is 13. So this simplifies to 2 times the square root of 13. Now, if I squared that to see if I got 52, that would be 2 squared, which would be 4. 13 squared root of 13 squared is 13, and that does equal 52. You don't have to do that. I'm just letting you know. Look at him. He's going, what? What? Do I have to do that? Do I have to do that? No. Okay, see this guy? We have stuff outside, and we have stuff inside. So here's what's happening. The square root is kind of like a jail cell, okay? You can't get out until you're perfect. So just like here, I had a pair of perfect 2's, so out came a 2. You have to be perfect to make it out. But outside is waiting for you. When you get out of jail, you got to have someone pick you up. So outside we have this 6. He's waiting outside, and then I'm going to put parentheses. What I'm going to do is set it up for simplifying. So this 6 does not get simplified because it's not inside the radical. I'm going to go down here and do that upside down division with 27. The first prime number that goes into 27 is 3. 27 divided by 3 is 9. I'm stuck with 3 until it stops working. 9 divided by 3 is 3. I'm stuck with 3 until it stops working, and I'm down to 1. Now remember how many have to be in a pair to be perfect? A pair of 3's. Remember, that's because 3 squared, the square and the square root cancel, and brings me out a 3. Anything else have a perfect buddy there that I could square? Nope. So what comes out? 3. What stays inside the radical? What didn't make it out? 3 times 1, which is 3. Now what you have is a problem that says 6 times 3 times the square root of 3. Which ones can I actually multiply together? I can multiply the numbers that are outside. So what's 6 times 3? 18. And what's left inside? The square root of 3. So here's what happens. Let me tell you what you're going to do wrong if you're going to do something wrong. You're going to take the square root of 27, you're going to go down here, you're going to hedge it, and you're going to say the answer is 3 square roots of 3, because you're going to forget about that 6. So I want you to do this setup. I want you to have it set up with who's already outside and what's going to happen when I simplify inside. Okay, oh, look at, see, he's perfect. He cracked out of the egg. Little chick came out of the egg. Setup time, 3 square root of 16. Okay, so I'm going to go over here. I'm going to hedge 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. I'm looking for a pair. Pair of 2's comes out as a big 2. Pair of 2's comes out as a big 2. Everything outside gets multiplied. 2 times 2 is 4. What's left inside? 1. Well, here's the deal, guys. The square root of 1 is 1. That's because 1 times 1 is 1. Okay? Oh my gosh, I'm such a silly Willy. Was 16 a perfect square to start with? If it is a perfect square and you recognize it, you don't have to do that hedging. You can just say the square root is coming, or is simplified. The square root of 16 is just 4. So now everything's outside, there's nothing left inside, so my answer here is 12. Okay, so here we got to set up the 2, get ready for the square root of 25. Oh, 25 is one of those perfect squares. Here's what you might want to write down. Let's take a little pause. 1 squared is 1. 2 squared is 4. 3 squared is 9. Are you writing these down with me? 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Those you better have committed to memory. Then this makes your life easier if you know 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. If you know your first 15 perfect squares, that's really going to help you. You know where it helped you last time? It helped you in x squared minus 121. You would know to factor that to x plus 11, x minus 11. So know these perfect squares. Make sure those are written in your composition book. We want to see them. So is 25 a perfect square? It sure is. What is the square root of 25? 5. Remember, when you're answering what is the square root, you're saying what times itself gives me 25. Nothing's left inside, everybody's outside, so 2 times 5 is 10. I'm feeling a checkpoint. Are you feeling a checkpoint? Oh my gosh, I'm not psychic. I thought there would be a checkpoint. Okay, look at him. He's looking at me like, what you thinking about, woman? There is no checkpoint. He's going, checkpoint, checkpoint. What's a checkpoint? Checkpoint, checkpoint. Let's move on. Okay. Ooh, look, here's kind of a little radical right there in the little chick's feet. Simplifying square roots with variables. Okay, so numbers we can hedge. Variables we can also hedge, because let's look at the square root of x to the 4th. How many x's is that? That's 4. 1, 2, 3, 4. So there's a perfect square, brings out an x. There's a perfect pair, brings out an x. X times x is x squared. Let's look at the square root of x to the 10th. I'm going to write them sideways because I'm out of room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a pair of x's, brings out an x. A pair of x's 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 brings out an x. 1, 2, 3, 4, 5. That equals x to the 5th. What do you notice about the original power and when I take the square root? 4 becomes 2. 10 becomes 5. It's just divided by 2, isn't it? So if you have the square root to an even power, the answer is just that even power divided by 2. Now here's where the problem comes in. What if I take the square root of x to the 5th? That's 1, 2, 3, 4, 5. Pair of x's brings out an x. Pair of x's brings out an x. X times x is x squared. Uh-oh, I have an x left inside. He didn't have a partner. So I feel like I should do orange for these guys' feet, huh? Let's do the square root of x to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 1, 2, 3, 4. So there were 4 x's that made it out, 1 that did not. So if you have an x to an odd, for right now, you're going to rewrite it as x to the even, and it's going to be times x to the 1. So it's going to come out to x to the even divided by 2 times the square root of x. So let's look at that. This x to the 5th, I would have rewritten, I would have gone down to the next even number, which is 4 times x to the 1. 4 divided by 2 is 2, leaves one of those x's inside. Here, I would have rewritten this as the square root of x to the 8th. 9 is odd, take it down 1 to make it even, and x to the 1. Because remember how we do x to the 8th times x to the 1? That's 8 plus 1, which is 9. 8 divided by 2 is 4, leaves me with an x. All right? Here we go. So I'm going to kind of in my head look at this. 4 is even, 10 is even. That makes me happy. What I'm doing is I'm taking 4 divided by 2 and 10 divided by 2. So that gives me a squared b to the 5th. Bada bing, bada boom. Nothing was odd. Everything stays inside. Here, the first thing I'm going to do is the 25. I'm going to do the square root of 25. I would hedge it, but I happen to know it is 5. Then I'm going to look. Is this even? Yes. Is this even? Yes. Is this even? Yes. So that means everything's going to come out. Everybody that's even comes out. So there's 5. What I'm doing, remember, when I take it out, is dividing by 2, dividing by 2, dividing by 2. So it's going to be x to the 3rd, 6 divided by 2, y to the 6th, 12 divided by 2, z to the 1st, 2 divided by 2. Look at these guys. This is the guy that's just going, I don't get it. It's so confusing. He's going, what you talking about, woman? He's going, food? Food? Is there food? 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 He's looking over here going, I'm with you, buddy. I don't get it. He's going, it's okay. You're going to understand it really soon. And that's what I'm going to tell you. Let's go to the next slide because we got to practice this. So here we go. 2. Is there a square root of 2? Well, if I divide 2, I just get 2. It is not. So I'm going to leave it inside. This is odd. And this is odd. So I'm going to rewrite it as x to the 6th x, y to the 8th y. Always rewrite it with the evens. Now, what comes out? This one and this one are even, so I'm going to divide them by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Everybody else didn't make it out. So the 2, the x, and the y stay inside. All right, I'm going to take this 45 and I'm going to hedge it. I'm going to go over here and I'm going to hedge 45. This is getting pretty long. So that's divided by 5, which is 9. Divided by 3 is 3. Divided by 3 is 1. So I'm bringing out a 3 and I'm leaving in a 5. At this point, I'm going to make sure everybody is even. He is not. So I'm going to rewrite that as b to the 4th b and keep this as c to the 6th. So I keep the 3 and then I do the setup. A to the 4th is even. 4 divided by 2 is 2. B to the 4th is even. 4 divided by 2 is 2. C to the 6th is even. 6 divided by 2 is 3. Who is left inside? A 5 and a b. Now I got to just multiply. So I have 3 a squared b squared c cubed times the square root of b to the 5th. Holy McMullenstein, Batman. Okay, there's our checkpoint. So you're going to simplify. Square root of 4, if you know it, do it. A squared b cubed, you got an even, you got an odd. Break that b cubed down. 4, set this one up as 4 and then be waiting on what you get when you simplify it, okay? Do your checkpoint, moving on. Rationalization. Oh my gosh, this is what you're all going to look like right here. This is going to be you when you are rationalizing. You're going to go, what? Here's the deal. You cannot leave a radical, are you writing this down? In the denominator. You cannot. So you are going to do what's called rationalization. A radical is called an irrational number. We want it to become a rational number, a number that makes sense. The square root of 3 doesn't make sense to us. So what you are going to do is you are going to multiply both the numerator and the denominator by the denominator again. Okay, we'll talk about what that actually means when we do a problem. So write that down. We might put an asterisk there because we might change it a little bit depending on what we have in the denominator. Alrighty, so we've got the square root of 12 or the square root of 5. First thing I want you to do is if they're both under square roots, I want you to ask yourself, can you simplify? If they're both under square roots, you can try to reduce it. For example, if you had the square root of 6 over the square root of 3, that's the same thing as the square root of 6 over 3, which would be the square root of 2. Here's the deal. You can't do that on any of this, but I wanted to talk about it. So this is what I said. You're going to multiply both the numerator and denominator by the denominator. The denominator is the square root of 5. Now remember, everything inside the radical can get multiplied. Everything outside the radical can get multiplied. So up on the top, inside, I have 12 times 5. On the bottom, I have the square root of 5 times 5. Okay? 5 times 5, remember, is 5 squared. So what does that come out as? It just comes out as 5. 12 times 5 is 60. So I'm going to go over here and I'm going to hedge 60. All right? For the sake of time, I'm doing a little zippy hedging because we're getting a little tired. This is a long video. The 2's come out. I have 2. 3 times 5 stays inside. So it's 2 times the square root of 15 over 5. Okay? What came first, the chicken or the egg? That's what we're trying to figure out. Right now, we're just trying to figure out, this is hard stuff. So we're going to do a few more. Got a radical in the denominator, so I have to do what's called rationalizing. I do that by multiplying by the square root of 3 over the square root of 3. For guys, or you're going to be, we got some stars, we got a visitor here, so if you hear some talking in the background, we're just going to say, hello, Brandon. Everybody say, hello, Brandon. Hello, Brandon. Okay, never mind. All right, so up on top, I'm going to multiply 8 times 3 because they're both under the radical, so that's the square root of 24. On the bottom, 3 times 3, I'm just going to leave it as 3 times 3 because we know that comes out to 3. You know what, guys? You can skip that step. If you have the square root of 3 times the square root of 3, it just equals 3. Let's hedge 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. Divided by 3 is 1. You bring out a pair of 2's. Inside 3 times 2 is 6. So your answer is 2 square roots of 6 over 3. Okay? Now, for those of you that are worried about me, I'm not talking about the pictures. Oh my God, except look at this one. That much because this is a really long video, but I love this picture. Isn't that cute? We love everybody. We love all our little chicks. I love it. I love it. I love it. So sometimes it's all under one big radical. Sometimes it's under 2 different radicals. This one, though, it's the same thing as the square root of 15 over the square root of 2. So in order to rationalize, I'm going to multiply by the square root of 2 over the square root of 2. Remember, we just talked about that. That just gives us a 2. Again, that's because it's 2 squared. Square and square root cancel. 15 times 2 is 30. So I'm going to go over here and I'm going to hedge 30. Remember, I'm doing zippy hedging now because I'm kind of tired of this. It's been a really long video. Oh, nothing happened. Nothing comes out of that. So it's just the square root of 30 over 2. I can't divide 30 by 2 because 30 is inside, 2 is outside. Now on this one, this is the same thing as 5 over 15. Does 5 over 15 reduce? It does to 1 over 3. So if you see that and if you can reduce, you're going to be dealing with smaller numbers. So I'm going to do this 2 ways. I'm going to pretend I didn't see that. So I would have the square root of 5 over the square root of 15. In order to rationalize, I'm going to multiply by the square root of 15 over the square root of 15. We know on the bottom that gives us 15. On the top, that gives us the square root of 75. So I have to hedge that. 5 goes into 75. That's not a 2. Come on, Evans. 15 divided by 5 is 3. Divided by 3 is 1. I've got a pair of 5's. So I bring out a 5. I have a 3 left inside over 15. Now here, I'm glad I did it this way because here's a new thing. 5 and 15 are both outside of the radical. That means I have to go back to 3rd grade. Can I reduce 5 over 15? I can. 5 goes into 5 once. 5 goes into 15 3 times. But I have to leave that square root of 3 up there. Okay? Second method is if I did see that it's the square root of 1 over the square root of 3, I could rationalize by just multiplying by the square root of 3 over the square root of 3. Up on the top, that gives me the square root of 3. On the bottom, it gives me 3. Do you see how this is a bada bing, bada boomer, but we get the same answer? So if you see that you can simplify inside, do. If not, you're going to have to simplify at the end. 6 of one, half a dozen of the other. And by the way, I just love these. Are they just not absolutely adorable? This is my favorite. Okay. Oh, okay. He's kind of scary. I think what he's saying is do the checkpoint. All right. So some of these, as I'm just glancing at them, they can simplify. Do that first. It's going to make your life easier. If not, remember you are rationalizing. Multiply both the numerator and denominator by the denominator. I believe this one wins longest video yet. See ya.